How's it going, geometry kids? Today we're looking at inscribed angle. Inside, scribed, angles. Okay, inscribed angle is an angle that lies on the circle. Okay? And then it intercepts an arc. Okay? It's inscribed inside a circle. And it has an intercepted arc. Got it. Oh, I hit the wrong button. What's I gonna do? Nothing. Okay. An inscribed angle is 1/2 the measure of your arc. So like if this was 80 degrees, my angle would be 40 degrees. Okay? Not too bad. Not too bad. Some corollaries. Corollary 1 I call the field goal kicking phenomenon. Imagine here's a field goal post, right? And imagine if I made a circle with a radius of that went onto the field. It'd be like this, right? You know, they always say, hey, line the ball up in the center for your kick because that means you have a better angle, right? But check this out. Let's say I'm kicking from right here, right? I go to kick a field goal. Okay? And let's say I'm dead on. And I go to kick a field goal. Okay? Now, let's be curving around to. What do I know about these two angles since they intercept the same arc? They are congruent. So your angle is the same whether you're on a hashtag or dead center in football. It's a matter of your mind thinking you have less of an angle. Okay? And I can verify this. I actually took abstract geometry with the guy who kicked for SKSU, so he actually concurred. If an angle's inscribed and it makes a half circle, it's 90 degrees, because half of 180 is 90. That's a silly one. The next one is, if you take a quadrilateral and you inscribe it, the opposite angles are supplementary, apt 180. So like angle D plus angle B, it's 180. And angle A plus angle C would be 180. Okay? Okay. Let's try it out. Okay. When I look at angle 4, okay, I see that this arc from here to here is 140 degrees because it's 60 plus 80, right? Right. Okay. So that means angle 4 is going to be half of 140, which is 70 degrees. Okay. Got one of them done. Okay. Now I also know, because it's quadrilateral, that they're going to add up to 180. But I'm going to use something else. This is diameter, right? So it makes up half of the circle. So this arc is going to be equal to 180 minus 60, right? Which is 120 degrees. And I get that from these have to apt to 180, right? So that tells me that angle 3 is going to be half of 120. I'm sorry, not half of 120. I didn't need to find that. This tells me the measure of angle 3, since it makes up a diameter, is half of 180, which is 90. Okay. And then my measure of angle 1 is going to be half of 180 as well because that's a diameter, so it makes up half a circle. 180. And last but not least, the measure of angle 2 is going to be equal to, well, if this is 120 degrees, this side's 100 degrees, right? So this whole arc is 220. Which is 110. Or you could have done 180 minus 70, which is 110, by using the corollary that these two angles are supplementary. Okay? Okay. Next one is, if you have a tangent and you're making a line, so we have this guy coming in, making a tangent, only hitting once over here, and you're making an angle, and you have an intercepted arc, then your angle is twice the measure of your arc, or your arc is half the measure of your angle. Okay? For example, if my angle was 60 degrees, this arc would be 120. Okay? Okay? This is where things get hard. Okay. So this is 35 degrees, right? I need to find x and y. Well, I'm going to find y first. This angle up here is 90 degrees. How do I know that? Because look, that's a semicircle, passes through the diameter. And half of 180 is 90. So that means angle y is going to be equal to, well, 90 plus 35 plus y, it's going to be 180, right? So y is going to equal 55 degrees. Okay? So now, I have y. How do I find x? How am I going to do this? This is crazy. Well, let's find arc JL. If this angle's 35, what do I know about this arc? Well, it's going to be 2 times 35, right? Which is 70. Okay? Right? So JL is 70 degrees, this arc. Now our theorem before says half our arc length is equal to our angle, so we got it. So actually, x is going to be equal to half of, so I know we're being around it here, 35 degrees. X is equal to 35 to your angle JQL. Okay? Phew. They're always going to be the same, guys. The angles are always going to be the same. That's part B. That's what we just proved. And that's it.